Hey guys, Miss Miklos here, and in this lecture, we are going to be dealing with even more word problems, and I know you guys are all happy about that. And in today's word problems, obviously, everything that we draw out is somehow going to form a triangle, and today they are going to be non-right triangles, which means we will need to determine if we should use the law of cosines or use the law of sines, which we have previously learned in this chapter. So our first problem, after walking for 210 meters, Will makes an 80-degree turn and walks for another 174 meters before stopping. How far is Will to the nearest meter from his starting point? Okay, so I think I've told you guys this before, but I am a horrendous artist. So I'm just really going to draw a triangle here. So Will is starting and he's walking for 210 meters. So there is our 210 meters. And then he makes an 80-degree turn. And I know that the 80-degree turn needs to be inside the triangle because this portion right here is actually 280 degrees, which is too much for a triangle. Okay, and then he walks for 174 more meters. And then he stops. So here is Will right there, and he's just hanging out there. And we want to know how far away is Will from his starting point. So I'm going to call that X. So we need to determine, based on the information that we know, which law should we actually use. And I know I cannot use Pythagorean theorem because this is not a right triangle. And looking at the information given to me, it looks like I only have one angle here. So I'm thinking that we are going to have to use law of cosines. Okay, we know with law of cosines, I need to use the opposite side from whatever angle we are using in the formula, and that opposite side needs to be isolated. So when I set up my equation, I have x squared equals 174 squared plus 210 squared minus 2 times 174 times 210 times the cosine of 80 degrees. And this is nice because my x is pretty much isolated. So I'm going to go ahead and put everything on the right side of the equation into my calculator at once. And I definitely need to remember when I'm putting this in my calculator that I am in degree mode versus radian mode. Okay, that should be something that we check every single time just to make sure that we are going to get accurate answers. And when I put that all into my calculator, I get 61685.79118. And I know that I want to go ahead and keep that entire value in my calculator, and I don't want to round until the final answer. So I'm doing square root, second negative, which gives me the previous answer. And I get 248.366. And if we look back at the original problem, it told us to round to the nearest meter. So that would be 248 meters. So using law of cosines, we determined how far away Will was from his starting point. Problem number 2 says Skylar and Jaron decide to go snowmobiling. They start at the same point and drive at 10 kilometers per hour and 12 kilometers per hour respectively, and they diverge at an angle of 110 degrees. Sorry, I forgot to type that in there. And it's important because otherwise we couldn't solve the problem. So anyways, 2 hours after leaving, they find that their radio transmissions are barely audible. How far apart are they? Okay, so here Skylar and Jaron are going along, and this is 110 because that's how far apart it said their angle was. And I'm really trying to find this length here. How far apart are they? Now, this is a little bit different because they're giving us speeds rather than giving us a distance. And I know that if they've been traveling for 2 hours, okay, because it says 2 hours here, if Skylar's traveling at 10 kilometers per hour, she must have gone 20 kilometers. And if Jaren was traveling at 12 kilometers per hour, she must be going 24 kilometers. So at this point, I have enough information in my triangle. And once again, it looks like we are only dealing with one angle. So I'm thinking we are going to use the law of cosines again. When I set up my problem, I have x all by itself because that was opposite from the 110. And once again, this is something that I can go ahead and put into my calculator. So I'm going to go ahead and put that in now. And x squared, I get 1304.339, blah, 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 blah. And then I need to square root that value. So when I square root it, I get x equals 36.1 kilometers. And looking at it, this answer would be a reasonable answer because this is the largest side and we know it's opposite the largest angle. Okay, so most of our word problems here, I think a lot of the time we see a word problem and we kind of freak out. But I want to stress to you guys that really it's just like the problems we learned, except we only need to find one missing thing. So as soon as I draw out my triangle, it isn't that tough to deal with. Our last problem for today, number 3, it says, the side of a hill has a slope of 52 degrees with the horizontal. Sean is standing 100 meters from the base of the hill. He spots Aaron on the top of the hill with an angle of elevation of 31 degrees. What is the distance of the slope from the base up to where Aaron is standing? Okay, so this one sounds a little bit more complicated. So let's go ahead and kind of draw this out. Okay, so it's telling us that there is some sort of hill that has a slope of 52 degrees with the horizontal. It also tells us that we have Sean here who is standing 100 meters away from the base of the hill and looking up to the top of the hill with an angle of elevation of 31 degrees. Let me change colors here and make this like my hill. He spots Aaron up here, just hanging out by himself. And it says, what is the distance of the slope from the base up to where Aaron is standing? So we're trying to find this side right here. So this one was a little bit complicated to draw out. And what makes this weird is our hill actually does not form a triangle at all. In fact, the triangle's drawn with where Sean is, Aaron is, and the base of the hill. And the problem is, at the moment, we do not have enough information in this triangle to go ahead and solve our problem. However, I know that since this is a horizontal line, these two angles are a linear pair, so I know that they have to add up to be 180. So this would be 128 degrees. As soon as I know these two angles of the triangle, I know the third angle because I know all my angles need to add up to be 180 degrees, so this would be 21 degrees. So if we look at it, this time I know multiple angles, so I'm thinking we're probably using the law of sines. Now if I look at our triangle, the two sides we're talking about are 100, so I'm going to have to use 21. So I'm going to do something like sine of 21 degrees over 100. And if I look at x, that is opposite from 31. So I'm going to say sine of 31 degrees over x. So this is the equation that we have to solve in order to find the distance up the slope. So I'm going to go ahead and cross multiply here. So I have x times the sine of 21 degrees equals 100 times the sine of 31 degrees. And then I need to divide both sides by the sine of 21. And this is something then I can go ahead and put into my calculator. And I end up getting that x is equal to 143.7 meters. And once again, this answer seems reasonable because I know opposite from 21 degrees, which was our smallest angle, it was 100 feet, or I'm sorry, 100 meters. So since 31 degrees is bigger, I know this distance should be bigger as well. So hopefully this quick video gives you guys a little insight as to what we need to do when we are solving these these non-right triangle word problems.